Welcome to the lecture number 11. So in this lecture we are going to study the property number 7. In previous lecture we have seen the integral property. Now in this lecture we will see the derivative property. Okay. So what is this derivative property? Let us see. If Laplace transform of f of t is equal to f of s, then Laplace transform of f dash of t is equal to s into f of s minus f of 0. Second, Laplace transform of f double dash of t is equal to s square into f of s minus s into f of 0 minus f dash of 0. Third, Laplace transform of f triple dash of t, that is triple derivative. So what is that? S cube into f of s minus s square into f of 0 minus s into f dash of 0 minus f double dash of 0 and so on. Okay. So now to understand this property clearly, let us solve one example. Okay. So let us see this example. Now here given Laplace transform of d upon dt of sin t. Okay. So now comparing with Laplace transform of d upon dt of f of t, what we can write here? We get f of t is equal to sin of t. So first of all, what we have to do? First of all, we have to find the derivative of sin t. Okay, isn't it? So now how to find the derivative of sin t? We know that Laplace transform of f of t is equal to Laplace transform of sin t. So that is equal to, what is Laplace transform of sin t? 1 upon s square plus 1. Okay. So this is value of f of s. This is value of f of s. Okay. So now by using derivative property, what we can write here? So by using derivative property we can write here, that is Laplace transform of f dash of t is equal to, what is formula? S into f of s minus f of 0. So now first of all, here we can write this as f of t is equal to sin t. So what is f of 0? F of 0 is equal to sin of 0, that is 0. So now Laplace transform of d upon dt of sin t can be written as s into f of s is 1 upon s square plus 1, okay, minus 0. So what is the final answer? So finally we can say that Laplace transform of d upon dt of sin t is equal to what? S upon s square plus 1. So this is the final answer. Okay. So now I hope you understand this. Now let us take another example. Example number 2. Find Laplace transform of d upon dt of sin t upon t. Now let us try to solve this example. How to solve this example? Okay. So now for that, first of all, given Laplace transform of d upon dt of sin t upon t. So comparing with Laplace transform of d upon dt of f of t, if you compare with this, what we get here? So the value of f of t here is sin t upon t. So that means we have to find the Laplace transform of sin t upon t. So for that, so now this is division property. So for this, let us find Laplace transform of sin t first. So we know that Laplace transform of sin t is equal to 1 upon s square plus 1. Okay. So now by using division property, Laplace transform of sin t upon t is equal to integration from s to infinity into f of s, that is 1 upon s square plus 1 into ds. Okay. So now if you simplify this, what we get? If you simplify this further, what we get here? So that is equal to that is nothing but tan inverse of s limit from s to infinity. Now put upper limit and lower limit. So tan inverse of infinity minus tan inverse of s, that is equal, what is tan inverse of infinity? Pi by 2, and this is tan inverse of s. But again we know that this pi by 2 minus tan inverse of s can be written as cot inverse of s. So this is cot inverse of s. So this is Laplace transform of small f of s, isn't it? So now as f of t is equal to, so this is equation number a, let us consider. Now f of t is equal to what? Sin t upon t. Okay. Now here we have to find the value of f of 0, isn't it? What we have to do? We have to find value of f of 0. So how to find this? Let us see. Now, to find f of 0. So here f of 0 is equal to what? Sin 0 upon 0, but it will be 0 by 0. So this is indeterminate form. Indeterminate form. So whenever there is indeterminate form, we know that what we do, we take the we use the L'Hospital rule. Okay. So now for that, and here what we have to do, we have to take the limiting value of this sin t upon t. So here what we have to do, f of t is equal to limit t tends to 0 sin t upon t we have to take. Okay. But when we put t is equal to 0 here we are getting 0 by 0. So using LH rule, using LH rule, what we can write here? So now here using LH rule, what we can write here? F of 0 is equal to limit t tends to 0. So derivative of sin t is cos t and derivative of t is 1. Now put the values, what we get? Now cos of 0, and that will be 1. So we here f of 0 is equal to what? 1. Now using derivative property, Laplace transform of d upon dt of sin t upon t is equal to what? S into f of s. F of s, what is value of f of s? Cot inverse of s, isn't it? Minus 1. So this is the final answer. Okay. So in this way we have to solve some numericals. Okay. Now next, example number 3, let us see. Find Laplace transform of d upon dt of t into sin t. So you can solve this example also by using this particular derivative property. Okay. Next, so now here you can solve this example at home. So this is homework example. Find Laplace transform of d square t upon dt square. Okay, d square t upon dt square of sin t. So let us find out this. If you have given this question, so let us consider there sin 2t. How to solve this question? So similar question we have solved, but here now it is d square by dt square. Now first of all, given Laplace transform of d square upon dt square into sin of 2t. Okay. So now comparing with Laplace transform of d square upon dt square of f of t. What we get here? So here we get the value of f of t as is equal to sin of 2t. So first of all, let us find the Laplace transform of sin 2t. So the Laplace transform of f of t is equal to Laplace transform of sine of 2t, that is equal to 2 upon s square plus 4. So this is value of f of s. Now by using derivative property, Laplace transform of f double dash of t actually, okay, the double derivative is given in the question, so that's why we have to use this formula. So s square into f of s minus s into f of 0 minus f dash of 0. Now we have to find the value of f of 0 and f dash of 0. So now to find f of 0 and f dash of 0, we have given, what is given? F of t is equal to sine of 2t is given. So what is f dash of t then? Derivative of cos sine 2t is cos 2t into derivative of 2t is 2. Okay. So here f of 0 will be 0, and what about f dash of 0? F dash of 0 will be 2. Okay, now put these values here. What we get? Laplace transform of d square upon dt square in bracket sine of 2t is equal to s square in bracket 2 upon s square plus 4 minus s into 0 minus 2. Okay, minus 2. And that's why what we can write here. So this can be written as now 2s square upon s square plus 4 minus 2. And if you cross multiply this, what we get? 2s square minus 2s square minus plus minus 2 4 is 8 divided by s square plus 4. Okay, what we get finally? So that is equal to this 2s square get cancelled, and we will get minus 8 upon s square plus 4. So this is Laplace transform of, okay, what is this? This is Laplace transform of d square upon dt square of sine 2t. This is your final answer, isn't it? In this way we can solve such type of examples. Okay, so I hope you understand this. Thank you very much.